back to Sky Lectures. We are still dealing with UTME Physics 2014 Type S. Now look at question number 8. Question number 8 states that we should calculate the escape velocity of a satellite launched from the Earth's surface if the radius of the satellite is 6.4 times 10 raised to the power 6 meters. Solution. Now, in solving this question, you must know the formula for escape velocity. You can download our video on gravitational field. You will understand this better. The formula for escape velocity, that is the V escape is actually square root of what? 2gr, where g is acceleration due to gravity and r is the radius of the Earth. This formula is very important in calculating for what? Escape velocity. To solve this, therefore, my V escape will be 2 times g is given to me as 10 times the radius of the Earth is also given to me 6.4 times 10 raised to the power of what? Of 6. 10 raised to the power of 6. Therefore, the escape velocity will be square root of, if you compute this properly, you will have it as 128,000,000. So the square root of 128 million will give you what? Look at it. The square root of this will therefore give us what? 11.313 in kilometer per seconds. Remember that this is in kilometer per second. That means if you do the square roots, then convert it to what? Kilometer. So that you will have your results in form of what? 11.313 kilometer per second. Now which option is that? That will be what? Option D. Okay, look at question number 10. Question number 10 states that one of the conditions necessary for an object to be in equilibrium when acted upon by a number of parallel forces is that the vector sum of the forces is A average, B 0, C negative, D positive. The right option here will be what? 0. Now, let me give a typical example of how how you can see question on equilibrium. Let's assume you have a metal roll like this, and let's assume there is a pivot here, then a pivot here. Okay, the weight will definitely act at the center. Okay, so let's assume we have a reaction as a result of this pivot, a reaction as a result of this pivot, and then let's assume there is a mass on at this position as well. So therefore, I can call this reaction 1, reaction 2. This is what? A weight. So let me call it W1. This is another weight, W2. Okay. At this point, we can therefore apply one of the principles in solving equilibrium, that what? Sum of upward force is equal to sum of downward force. So therefore, if I say sum of upward force is equal to sum of downward force, you can see the arrow. This is stipulating upward, while this shows downward force. Therefore, I can say R1 plus what? R2, the sum of it is equal to sum of downward force, W1 plus what? W2. Or better still, I can therefore say that what? Sum of all the force acting on this meter row, let them be equal to 0. Okay, I can as well say that sum of what? All forces acting on this meter row, let it be equal to 0. Then I will then decide to choose which one will be positive, which one will be negative. Obviously, I can say let the one going up be positive and let the one coming down be what? Negative. So therefore, since I say sum of all forces is equal to 0, that is why I pick this option as what? 0. Okay, so sum of all force will therefore be the one going up. I said let them be positive. So R1 plus R2 is also going up, plus, look at this one is coming down, put it into bracket, minus W1, okay, plus the addition here shows we are carrying out what? This summation. Okay, so plus another one coming down, that will be negative W2, and sum of all the forces, look at it, summation of all the forces is equal to what? 0. At this point, we can say that what? The metal roll is said to be in what? Equilibrium. Okay, so the right option here will be what? Option 0. Option B here, which is what? 0. Okay, because of this rule I've just applied here. Okay, look at question number 14. For you to understand this better, you can download our video on equilibrium of forces. You will understand how to solve questions, different questions on equilibrium. It is well explained. Now look at question number 14. This question number 14 is on machine. Okay, you can download our video as well on machine. You will understand this better. Okay, now solution. We're told that a machine whose efficiency, we're given the efficiency of the machine to be 75%, is used to lift a load of 1,000 Newton. We're given the load to be in Newton, which is what? 1,000 in Newton. Now we're asked to calculate the effort. I'm looking for the effort represented with what? Small letter E. Okay. We're asked to calculate the effort put into the machine if it has a velocity ratio of 4. We're given the velocity ratio of the machine to be what? 4. We are looking for effort. But one thing is clear. Efficiency is what? Mechanical advantage over velocity ratio times what? 100%. Where this efficiency is expressed in percentage. Apart from that, you will notice that there is no effort in this formula. But you can actually graph it out. Why? Because we know that mechanical advantage is what? Load over effort. So therefore, I know my efficiency, I know my velocity ratio. With that, I can calculate for this mechanical advantage. Once I know my mechanical advantage, put it in here. We know the load. Now we have calculated for the mechanical advantage. We can easily calculate for what? The effort that is needed in the question. So therefore, let's get the mechanical advantage first. Our efficiency is 75 equals to mechanical advantage. The velocity ratio is 4 times what? 100. So this is like saying 75 being equals to 100 MA over 4. This over 1. If you cross multiply, therefore, 100 MA will be equals to 75 times 4 will give you what? 300. Therefore, divide 2 by 100 to get your mechanical advantage by 100. Therefore, my mechanical advantage will be this and this, and that will be what? 3. It has no units. Now, if my mechanical advantage is 3, now look at it here. And I know that what? My load is what? 1,000. 1,000 Newton. I can easily calculate it out. Putting my mechanical advantage into this formula, it will be 3 equals to the load is what? 1,000 over effort. So my mechanical advantage is 3, which is this. I know the load to be what? 1,000, and I'm looking for effort. Therefore, my effort will be what? If you cross multiply, okay, let's just cross multiply. So it will be what? 3E being equal to what? 1,000. Now let's divide 3 by 3 by 3. Therefore, the value of my effort will be what? 1,000 divided by 3, and that will give us what? Take a good look at it here. It will give us 333.33 in Newton. So this is the value of my what? Effort. And which option is that? That will be option C. Finally, look at question number 16. We're told that solution. We're told that a force, we're given the force to be what? 500 Newton. Is applied to a steel wire of cross-sectional area. We're given the area of the steel wire to be 0.2 in meters square. The units are okay. Okay, good. Now, the question states that what? The tensile stress is, this question is under elasticity. To get this question properly, you can download our video on elasticity. You will understand this better. Now, we know that tensile stress, which I can as well refer to as stress, the formula is what? Force over area, where F is force and A here represents area. And I'm looking for what? This tensile stress. So, therefore, my stress will be what? What is the force? 500 over my area is just 0.2. And if you divide that properly, if you compute that, you will have it to be what? 2,500 in Newton per meter squared. But the option is in standard form, so let's convert it If my stress is 2,500 Newton per meter squared, and I want to convert it to standard form, it will be the same thing as 2.5 times 10 raised to the power of 1, 2, 3 times 10 raised to the power of 3 Newton per meter squared. And which option is that? That will be what? Option D. So I want you to look at this carefully. We'll meet in the next class to deal with more questions on UTME Physics 2014 Type S. Thank you very much.